questions in this 2-hour session. Now, if you're interested, we do also have an AWS Certified Solution Architect official study guide. And if you haven't taken the 3-day class, you could refer to this study guide. Even if you did take the 3-day class, this study guide has some review questions, and it is available at Amazon.com if you're interested in purchasing this guide. Now, the questions are allocated across different domains. So you have 34% of the questions around designing resilient architectures. You have 24% around making sure that your solution is performant. And then you have 26% with the security aspect of it. 10% is cost optimized, and then 6% is the operationally excellent architecture pillar. So usually when you take the exam, you go to a testing center and you need to provide 2 forms of ID. You just need to make sure that you don't have anything in your pockets. You're going to be given a locker. You're going to put everything in there, and you're going to be signing a non-disclosure agreement. The exam is going to be about 130 minutes, roughly between 55 and 60 questions, and it is multiple choice. So what you want to make sure is when you go through the questions, you identify the features mentioned in the answers. So look for specific features, and I'll give you an example as we go through this session. And always remember that sometimes in the last sentence of the question, they'll say like, what is the most optimized or the most cost effective? Just pay attention a bit to that. Now, let's go directly into the first domain of the exam. So we're going to go to domain 1, and domain 1 is about resilient architectures. So what do you need to know for domain 1? So we're going to talk about a bit of storage, about decoupling, and look at high availability, fault tolerant in a multi-tier architecture solution. So we start off, just make sure that you know the difference between instance store and EBS volumes. Make sure you understand what happens when you stop an instance and it has instance store versus an EBS volume. And certain AC2 instance types support instance store where others don't have that option, right? And then on EBS volume, you need to remember that an EBS volume sits in the AZ, and it's not replicated across AZs, but we do make sure that within an AZ, it attaches to the EC2. It's persistent volumes, and you can take snapshots of it, and the snapshots do sit on S3. Now, the slide that you have right here, if you take a look at that, the types of EBS volumes, and I have this slide in the PDF file in the attachment. So what you have is in EBS volume, you have general purpose SSD. That's usually your boot volume. And if you take a look at the max IOPS per volume, it's about 10,000. And then you have provisioned IOPS SSD, right? And we tend to use those for if you're installing a database on EC2, IO intensive NoSQL versus relational. And then the max IOPS is about 32,000. And then you have throughput optimized HDD. And if you look at that one, the use cases, pay attention to the use cases. That one is for log processing, big data, data warehouse. And in terms, this time, instead of focusing on the IOPS, I want to focus on throughput. So you have look at the throughput that is on the slide. And then what you have is just cold HDD. And this is for infrequently accessed data, so large volumes of data that is infrequently accessed. And now you're looking at, again, throughput versus IOPS. And then we're going to go to the next slide. So if you have basically if you need to do any additional readings, I provided you with the FAQs. It would be good to go through the storage white paper to again review the different type of storage backend that you can have. So let's take a look at a sample exam question here. I have a database is running on Amazon EC2 instance, The database software has a backup feature that requires block storage. So what storage option would be the lowest cost option for the backup data? So keywords. So you have lowest cost option for the backup data, and it does require block storage. So Glacier is basically for archiving and not necessarily a block storage. And then S3, well, S3 is definitely not block storage. And the goal here is we said that we want the lowest cost option for the backup data. So Amazon EBS cold HDD volume would be the best answer in this example. Next question. A company has decided to host a server on Amazon EC2 instance. The main requirement for this server is to process large quantities of logs. So which of the following Amazon EBS volume types would be ideal for this implementation? So you have keywords here that we're looking at. So again, you have processed large quantities of logs. We're looking for the ideal implementation. So in one of our slides that I showed you previously, we looked at EBS throughput optimized HDD because when it comes to processing large quantity of logs, that would be the best storage option or the ideal storage option for that one. So this is an example of when to use EBS throughput optimized. Now, how do we decouple in an architecture with AWS services? So what we don't want is, for example, I have an app running on EC2, so a customer order web server, and it needs to basically talk to the applications, to the order dispatcher and then the application server. So what I can do is if I'm sending messages from one server to another server, what I could do to decouple, one option is to use SQS queues. So make sure that you review what are the types of SQS queues. So you can have a standard queue and you can have a FIFO queue. And then make sure to review the difference between a standard queue and a FIFO queue. But in this design, what we're trying to show you is that to decouple the producer from the consumer, we're using an SQS queue. So now another option that we can also use for decoupling and for scalability, in this use case, what I have is instead of having the web server directly talking to the logging service, if the logging service fails, well, first of all, I don't have a resilient architecture and it's not scalable. So what I have here is the web server. I have a load balancer, and then I have my logging service in an auto-scaling group. And then what I have on the back end is a NoSQL database with DynamoDB. The focus here is decoupling. And what I'm using to decouple in this example is a load balancer. So when you look at AWS load balancers, you have application load balancers and you have the network load balancers. So just remember to review the difference. The network load balancer operates at layer 4. And whenever you need high performance with TCP packets, so you would be looking at a network load balancer. The application load balancer operates at layer 7. And basically the keyword here too is it routes traffic based on content of the request, so within the URI. And it also supports TLS. Basically what you can do is add a certificate to the application load balancer, and you can have SSL if you want. Now, to fill your gaps, so what we did is in my document, I added information about the FAQs for SQS, the load balancers, the different type of load balancers, and the documentation also. So let's take a look at sample exam questions. It says here, which of the following AWS services facilitate the implementation of loosely coupled architectures? And notice that it says select two options from this list. So we have loosely coupled is the key word here. Now, CloudFormation is a service that allows us to automatically provision a environment. The environment, so everything we define in a template is provisioned through the CloudFormation engine, and once it's up and running, it's referred to as a stack. So you could either terminate the stack when you're done with the environment. So this has nothing to do with the question that we have. And then, so in the previous slide, we looked at SQS. SQS is one way to create a design architecture that allows us to create a loosely coupled architecture. Now, CloudTrail, on the other hand, is for auditing. So whenever you use the console, the SDK, or the CLI, any APIs that you're using in AWS are recorded in CloudTrail. So that's for auditing purposes. And it's not the answer for the loosely coupled architecture. And then EMR basically is a Hadoop, if you want, managed Hadoop cluster, or you can run Spark or any processing framework. So it's not the correct answer. So your answers are Amazon Simple SQS and then Elastic Load Balancing, and you can have an application load balancer or a network load balancer. So now, how to design a multi-tier architecture solution. So basically, review a bit what EFS is, the Elastic File System. So think of NFS or SMB. So whenever you want to share, EFS is for NFS. So whenever you want to share a file system across two EC2 instances. Now remember, EBS cannot be shared with another instance. EBS is attached to that EC2 instance in the same AZ, where EFS can be shared. It's a file system that can be shared across multiple EC2. And in this case, EFS is for NFS, but we do have also a version for Windows. But in this use case, it's NFS. It's Linux-based AMI for EC2 compatibility. So it is a managed file system by AWS. If you take a look at this architecture, what I have is some EC2 instances sitting in different AZs. And I have the EFS managed service. So think of it as like the backend NFS server, and then your clients, the EC2 instance, are like NFS clients. I'm trying to relate to what you might run into like in your on-prem environment. So you have NFS clients and NFS server. So your EFS would be the server side, and then your EC2 would be the NFS clients. And they would connect to that EFS share. And you can see that the EC2s are sitting in different AZs. And now they can access and share the same file system that is located on the Amazon EFS share. So review, make sure you understand very well Amazon S3 for object cloud storage. So you have 11.9 durability. Now with Amazon S3, what you have is different tiers. So you have the standard S3, you have infrequent access, you have one zone S3, and it's unlimited capacity. You can enable versioning if you want, and then you can have different types. So you can have server-side encryption, and we'll look at that in the next module. And then just remember the maximum object size is 5 terabyte. Make sure you understand the difference between bucket policies, IAM policies, and then bucket and object ACLs. So review that. And always remember that when you have a bucket policy, you have the concept of a principal. So in that policy file, that you would have a principal. In an IAM policy, you don't need to specify the principal, because what you're doing is assigning policies to users or groups. So just make sure you review that. And then understand the difference between S3 and Glacier. So Glacier is for archiving. So, which means that if you need to retrieve the data, you got to make a request to retrieve it. You can have expedited retrieval, standard or bulk. And what you can also do with between S3 and Glacier is set up a life cycle rule. So, for example, after 30 days, once your objects are in standard S3, you can move them to infrequent access after 60 days, and maybe after 180 days, automatically move them to Glacier. That would be called a life cycle policy. You can set up rules within a life cycle policy. Now, S3 and Glacier, they sit in the region. So with S3, the name is unique across all of the AWS, but the bucket itself and the objects within the bucket sit in the regions. And then Glacier also sits in the region, and 11.9's durability. So review the difference between EFS, S3, Glacier, and also what CloudFront does. And CloudFront is our content delivery network, or CDN. And then I put for you in the PDF file, if you want to go do some labs and just practice a bit, so you have some links to that. So just remember, when we're talking about high availability and fault tolerant, just remember everything fails all the time. So you always have to design with multiple AZs in mind, right? And put load balancers. So as an example here, back to my loosely coupled architecture, where I have my web servers, I have my app servers, and then in between that, I have a load balancer. So if I lose one of the app servers, or I lose, one of the web servers, so in both, doesn't really matter, because I can basically scale out and scale in I can put auto scaling on each tier, web tier and app tier. And then in between, I have the load balancer, and it's going to basically just redirect or send requests to whatever's available in terms of my app tier. So if I lose one app tier, I still have one server in my app tier. I still have my other servers that are located there. So we also have a well-architected framework white paper, so make sure that you review that. So let's look at some exam questions here. So I have your web service has a performance SLA to respond to 90% of requests in less than 5 seconds. It says under normal and heavy operations, distributing requests over 4 instances meets performance requirements. What architecture ensures cost-efficient, high availability of your service if an AZ becomes unreachable? So keywords again is cost-efficient, high availability, and then you have distributing requests over 4 instances meet performance requirements. So the first one, well, first of all, we basically never recommend using a single AZ. So we can cross that out right away. Whenever we have something that has a single AZ, it's not really a best practice. And then what we're looking at, the 2 last ones do look good, but we do ask you to have a cost-efficient high availability of your service. So C would be the ideal, the best answer in this example. Now, let's take a look at, again, a little review of CloudFormation. So what you want to do is think about whenever you build an architecture, after a while, you're going to get comfortable with the console and all that, and you want to be able to reproduce that architecture quickly and in a manner where you don't have to introduce any mistakes. You want to be able to reproduce the architecture in different regions and automate the deployment of it. So you have CloudFormation. So a few concepts or components in CloudFormation. What you do is you first have a template. In the template, it could be a JSON or a YAML template. You basically define the resources that you want part of. It could be a production environment, it could be a dev and test environment, it could be both. So anything that you need in your environment, you define it in a template. And then what you do is, once that's defined in the template, once you feed that template to the CloudFormation engine, it basically creates a stack. A stack is the collection of your AWS resources. And now if in your stack or in your template you had like a VPC, you had DynamoDB, you had S3, EC2, all the components that you defined are now up and running in your environment. And then that same template, if you have for example, a mapping section. So usually you have different sections in a template. You have a resources section, you have a mapping section, you can have a parameter section. You want to review a bit those sections. So I'm focusing a bit on mapping because what the goal is, it says I want to be able to reproduce this environment maybe in different regions. So you just need to remember that an AMI is per region, right? So if you don't have a mapping section, you can't define the AMIs for different regions. So to be able to reproduce this in a different region, I would have a mapping section. I would specify the AMI ID for different regions. And now I can launch this template in a different region. So exam question, sample question. You are planning to use CloudFormation to deploy a Linux EC2 instance in 2 different regions using the same base AMI. So how can you do this using CloudFormation? So it says here 2 different regions. So use 2 different AWS CloudFormation templates. Since CloudFormation templates are region specific, actually you don't have to do that. Well, basically, remember I said that you can just define, you have AMI IDs those are the ones that are specific to a region. You just create a mapping section in your CloudFormation template. And what you do is you make sure that you have the AMI ID for different regions. So, and then you don't need it says use parameters. So the parameter section allows you to ask the user, for example, if you want him to launch a small instance versus a medium instance type, you could prompt the user when they run the CloudFormation and it's asking for user input. That's what a parameter section is all about. So make sure you understand the difference between the sections, like parameter section, mapping section, output section, resources section. That's really important. And AMI IDs are not identical across region. What you would do is create an AMI from your EC2, and then what you can do is copy it to a different region, and you'll have your unique AMI ID. Now, Lambda. So Lambda is our fully managed compute service. So we refer to it as serverless compute because you are not managing the infrastructure. AWS is managing the infrastructure on your behalf. So, and you basically give it your code and it's going to trigger that code in response to an event. So make sure you understand the different components of Lambda. Like you have the Lambda function itself. You have a role that you would assign to the Lambda function. You would supply it with your code. So you just specify the runtime environment if you want Node, Python. And then what you would also, what you need to remember is it creates a log stream under CloudWatch logs. So for the logging information and anything about a bit like when your code runs, if there's any errors, it's going to be in CloudWatch logs. And always make sure you understand how roles work. So you're going to be assigning a role to the Lambda function. And the role needs to have, it's a trust relationship and a policy. So the policy, if your Lambda function gets triggered and it needs to run code that basically puts something in S3 as an example, well then your role has to have a policy file for S3, but it also has to have a policy file for CloudWatch logs. So Let's take a look at a question, exam question. How can I access the output of the print statement for the AWS Lambda? So you do not connect to Lambda. Lambda is serverless. You are not managing the infrastructure. There is no EC2. And you cannot connect to the backend that AWS has for you. So you cannot connect by using SSH. Now, Lambda writes all output to S3. That is not correct. And print statements are ignored. No. So it is, you could actually have print statements in your Lambda function, and it's actually good practice because you'll get more information in your CloudWatch logs. Okay, so exam consideration. So expect single AZ will never be the right answer, right? We always design with a minimum of 2 AZs. That's best practice. And use AWS managed services. Using AWS managed service should always be preferred. And then fault tolerant and high availability are not the same thing, and expect that everything will fail at some point and design accordingly. So just quickly, if I close this and I don't need this anymore, but if you look at the prep guide, so I basically in domain 1, I put together the where you need to look for your EBS versus instance store, and then this little table that compares the different types of EBS. A bit of information about decoupling, so SQS load balancer, designing the multi-tier architecture. You need to know about EFS versus S3 versus Glacier, a bit on CloudFront, and then also the difference between fault tolerance and high availability. It's right here, a bit on what CloudFormation does, and then your exam consideration. So now we're going to move to domain 2, which is designing architectures for performance. So let me go to domain 2 right here and open this up. So let's see. In domain 2, whoop, there we go. So we're going to look at making sure we understand a bit on databases, and again, just a little review with storage performance, and then focus a bit on caching, and then talk about elasticity and scalability. So in terms of, we said for EBS block storage, I already reviewed this table. So just look at the IOPS per volume, right, and understand the difference between throughput optimized and provisioned IOPS and just general purpose. Now, whenever we talk about S3, so look at the URL for the bucket. And remember that in S3, we don't really refer to files. They're referred to as objects. So you put objects in a file. And then normally when you upload a file, you put objects in a bucket. Sorry about that. When you upload an object to S3, you get an HTTPS link like you see at the following. So and that basically, that link is, by the way, private. It's not public by default, right? So it's always private. So your bucket, again, sits in a region, and the bucket name has to be unique across all of AWS, and it has to be in lowercase. Now, S3 can be used as a website, a static website to host your website. So you could have a virtual path. So the minute you enable S3 for website hosting, we provide you with a virtual path. Now, S3, the way you pay for S3 is per gig, it's gigs per month, but I also want to focus on, so there's no cost for transfer in, there is a cost for transfer out, and then there's the API requests like copy, post, list, and get. And an important point at the bottom right here, we said there's no cost for transfer in, and there's no cost for transfer out from S3 to another service in the same region. Let's move on. Now, in S3, there's different types of storage classes, right? So, and what you can also do for disaster recovery with S3, you can enable cross-region replication. For cross-region replication, you have to have versioning enabled. So, and then for the S3 storage classes, you have something called infrequent access, but you also have one zone. Don't forget about the one zone. Now, when you're dealing with infrequent access, you have a lower cost per gig, but because it's infrequent access, there is, I just want to point out, a higher cost for data that is recovered or accessed. And then you have the higher cost for put, copy, post, and get requests. 30 days storage minimum. Now, we talked about lifecycle policies that allows you to set up a rule and automatically then moves objects between standard and frequent access, Glacier, and then you could, if you want, at the end, add a delete. It's up to you. It's optional. So, exam question. In what ways does Amazon S3 object storage differ from block and file storage? So, you have Amazon S3 allows storing unlimited number of objects. We said that. It's true. So, you can have unlimited number of objects, and the maximum object size is 5 terabytes. And then objects are immutable. The only way to change a single byte is to replace the object. That's absolutely true. So if you have a file on EBS and you modify the first line of the file, well, then the bytes in the file change on EBS. But when you basically modify a file or object in S3, the entire object gets replaced. Next question. Which of the following are features of EBS? So remember that we said that EBS sits in an AZ. So data stored on EBS is automatically replicated within an AZ. Be careful with this. It says within an availability zone, not across AZs. So within an AZ. And if you want, you can also, you have the option to encrypt EBS volumes. Now, EBS volumes are not automatically backed up to tape. It's up to you to take snapshots, and we do have the option to set up a snapshot policy with a kind of like a lifecycle policy. So you could now set that up and have snapshots, and the snapshots will sit in S3. S3 sits in the region. And so snapshots are usually sitting in S3. EBS sits attached to an EC2 within an availability zone. So, and then the last one, you cannot attach EBS to more than one instance. If you want to attach a block or a file system like an NFS, you would use EFS. Elastic File System allows you to attach basically a file system to multiple EC2. Or share them across EC2. Now, in terms of database, review what RDS offers. So RDS is Relational Database Service. And then you have a managed service for NoSQL that Amazon created. It's DynamoDB. And then we have Amazon Redshift for data warehousing. So make sure you understand the use case. So for RDS, now remember RDS is the relational database service that supports different engines like one of them is Aurora, which is what AWS created. So you have Aurora, you have MySQL, you have Microsoft SQL, you have Oracle, you have MariaDB, you have Postgres. Those fit under the Amazon RDS umbrella. And whenever you're dealing with a relational database, so the use case would be like complex transactions or complex queries, medium to high query write rate, and then you have no more than a single worker's node or shard, and then you have high durability. Now, it do not use Amazon RDS for massive read-write rates, sharding, or simple get-put requests. There's a better option for that, or even RDB and S customization. So, and then always remember that with RDS, you can have a master and standby. You can also have read replicas. Read replicas not only can they be in the same region, but they can also be in different regions if you want. And they enhance the performance and durability. It's great for high volume applications, read traffic, right? You want to offload from the master so you can have read replicas, and then you can promote read replicas to standalone. And then DynamoDB, I said, is our NoSQL database. So so when it comes to a lot of heavy read-write for small reads and writes, so it's excellent for that. That's a great use case. And there's the concept of RCUs and WCUs, read capacity unit for an item up to 4K in size. And then there's write capacity unit. You also have the concept of strongly consistent reads and eventually consistent reads, which is half the price of strongly consistent reads. So a sample exam questions, which use case is ideal for RDS database engines? So remember that slide that we just had? So you have complex transactions and then medium to high query write rate. So that would be RDS. And then you have which AWS database service is best suited for non-relational databases. So DynamoDB is for NoSQL, that's your non-relational database. Redshift is a relational database, so it's for data warehouse and big analytic type of queries. And then we already explained what RDS is, and Glacier really is for archiving. It's not a database service. Okay, so another exam question. An application requires a relational database with initial storage capacity of 4 terabytes. And the database will grow by 10 gig every day. To support traffic, at least 4 read replicas is required to handle the reads. So which option will meet these requirements? Now, you basically, key word here is relational database. So I can already eliminate quite a few, or at least a couple of answers. And it says here the database will grow by 10 gig every day. Initial storage capacity is 4 terabyte. And then you have read replicas. So the best answer, so DynamoDB definitely doesn't fit here. It's NoSQL. You have S3's object storage, Redshift. So it is a relational, but it does not support the read replica and does not automatically scale in the term of the way they're putting it in this question. That's for analytics and data warehouse. So it's a bit of a different architecture. So Amazon Aurora would be the right answer in this exam question, sample exam question. So make sure you review the features of Amazon Aurora. Now, let's talk about caching a bit. So you have CloudFront. So that's our CDN, and you can cache static or dynamic content. So the origins for CloudFront can be S3, EC2, a load balancer, or on-prem servers. And then what you can also do is add a web application firewall to CloudFront. And it also, from a security, by default, supports Shield standard, but you can also have advanced Shield. So as an example, make sure you understand how CloudFront works. Remember that when a user makes a request for content, it goes to the closest CloudFront edge location. If it's not in there, it goes back to the origin. So so in this case it's F3, and then it brings it back to the edge location. So the next time the user makes a request, it hits the edge location, the copy is in cache, so then I quickly return the request. So what are we achieving here? So from a user perspective, they're getting a better experience. It's reducing the latency time, right? And if another user is located in the same area and makes the same request, well, again, it's going to hit the edge location. Now, if a user is located in a different area and the content has never been accessed, then it goes back, checks the edge location. If it's a miss, then it goes back to the origin again. and it brings it back to the edge location. Just make sure you understand how this works. And then now I'm talking about a different level of caching. So I'm going to use a service called Elasticache. And this time what we're caching is, it could be user sessions, it could be so session information, it could be database queries, key value pairs. So in this case, my Elasticache, you see how I have my applications. What they're going to do is go to the back end, like a DynamoDB, a relational database, or your own MongoDB that is running on an EC2 instance. I retrieve the data or the key value pair, and basically I can store it in cache. And then the next time when I retrieve it, it's in cache, and I don't have to go stress and put stress on the back end databases. So there's two types of open source cache engines for Elasticache. You have Memcached and Redis. Just make sure you review the difference between Memcached and Redis. So sample, an exam question would be which of the following, or a sample exam question, which of the following objects are good candidates to store in a cache? So you can have session state, shopping cart information, product catalog. Those are excellent candidates for cache. So which of the following cache engines are supported by Elasticache? So we mentioned that it's Memcached and Redis. And then just quickly on elastic scaling. So you can have vertical scaling versus horizontal scaling. Make sure you review. So vertical scaling means adding more CPU memory. So going from a small instance type to an extra large. And then horizontal scaling is adding more resources. For example, adding more instances, and it's scaling in and out. The other one is scaling up and down. Make sure you review, so there's AWS auto-scaling, and then there's EC2 auto-scaling. Make sure you review that. So with EC2, you could put them in an auto-scaling group and scale your backend, right? If you want, with auto-scaling, you can manage scaling for multiple resources. You can predefine your scaling strategy. Make sure you review CloudWatch and the type of metrics that are available by default on an EC2 versus, you can add your own custom metrics or install a package that will give you additional metrics if you want. And the default, every 5 minutes, we collect metric information. Now, when it comes to implementing continuity, so we'll just say that I have my EC2 instances in an auto-scaling group across different AZs. You have a load balancer in the front, and then you have CloudWatch. So you have CloudWatch, auto-scaling, and load balancer all used to implement an architecture that is highly available and that will scale out and scale in based on your CloudWatch metrics, or your CloudWatch rules that are set up, your auto-scaling rules that rely on, like, if CloudWatch metric, if the CPU is greater than 80%, then scale out. If the CPU is smaller than 20%, scale back, and that would be an example of a design implementation. So which services work together to enable auto-scaling of Amazon EC2 instance? I just mentioned it. Normally what you would see is EC2 auto-scaling, your Elastic Load Balancer, and you would have CloudWatch. They all work together in that design. Okay, so in my study guide, I made sure that I gave you information on the links to FAQs for ELB, CloudWatch, and EC2 auto-scaling. So another question is, a radio station runs a contest where every day at noon, they make an announcement that generates an immediate spike in traffic that requires 8 EC2 instances to process. All other times, the website requires 2 EC2 instances. So it's only every day at noon that they make that announcement. So which is the most cost-effective way to meet these requirements, right? So Let's take a look at this. So it says create an auto-scaling group with a minimum of capacity of A at all times. Not necessary, because it's basically every day at noon that it generates that spike. So that's a bit too much, because we're looking for the most cost-effective way. And then it says at the bottom here, it says create an auto-scaling group with a minimum of 2 and scale up based on that. I think we can do better than that. So then I have create an auto-scaling group with a minimum capacity of 2 and scale up based upon CPU utilization. That might take a while. Your best answer would be to create an auto-scaling group with a minimum of 2 and set a schedule to scale up at 11:40 a.m. So it's pretty clear in the question. It says a contest where every day at noon they make an announcement. So that would be the best cost-effective answer. So which of the following are characteristics of Amazon EC2 autoscaling? Select 3 answers. So it is the job of the load balancer to send traffic to the back-end instances that are healthy, or if an instance is not healthy, it puts it out of service. So the job of our autoscaling, of the EC2 autoscaling, is to respond to changes by basically launching or adding EC2 instances. CloudWatch is the one collecting the metrics, so that's not autoscaling. And SNS is responsible for push notifications. Now, when you create and you configure your auto-scaling group, you're going to need to specify a min, a max, and a desired. And then you also need to specify in your launch configuration your AMI. So those are the 3 answers, B, E, and F. Okay, so exam consideration, use caching. And then if data is unstructured, Amazon S3 is generally the storage solution. Make sure you understand auto-scaling and choose the instance and database type that makes the most sense of your workload. And again, in my notes, if I quickly just go to the notes again. So in domain 2, I put some references for you. You have the difference when to use RDS and do not use RDS, DynamoDB information, Redshift and caching information. Make sure you understand that. And make sure you understand how scaling works. So let's go to domain number 3. So just move this a bit. There we go. Now security, and let's take a look at this. Now, the first thing you need to know about is IAM, Identity and Access Management. So you have users, groups. So users go into groups, right? You can't have nested groups, but users can belong to multiple groups. And then what you do is you assign policy files to groups, or you could assign to users. Best practice is always to assign it to groups. It makes it easier to manage a bit. So, and then what you do, the policy file, which is a JSON file, determines which AWS resources users or applications can access. Now, a policy file can be assigned to groups or users, like I said, but a policy file can also be assigned to roles. So make sure you're clear on the difference between roles and policy. A role is temporary credentials, like you're getting temporary token. So a role has a trust relationship and a policy file attached to it. And then you could have users that are local to IAM, but you can also have federated users. So if on-prem in your data center you have Microsoft Active Directory or any type of corporate data store, you don't have to recreate those users in IAM, in the local IAM. So what you can have is the users are federated, they get authenticated, they get a token, and then they get access to our services. So they come in with a role. and always use the principle of the least privilege. So I talked about users and groups. Roles can be assigned. So roles have 4 use cases. The first use case is when a service needs permissions to talk to another service. I gave you the example of Lambda needs a role. So whenever it's talking to S3 or DynamoDB, so it needs a role. Whenever your EC2 instance, if you have programmatic or CLI access on your EC2 instance, let's just say you go to the EC2 instance and you are allowed to launch it based on your policy, but then you go to the command prompt of the EC2 instance, and now you're going to run a CLI command, and that needs to list your buckets are in S3. Well, that's basically CLI access. Or if you run a Python script that needs to programmatically upload stuff to S3 from your EC2 instance, well, that's programmatic access. So the EC2, the best way to do is assign a role to that EC2 instance, and that role has a trust and then policy file that is S3, and now it could basically access S3. So that's one use case. The second use case of roles is for cross-account access. The third use case of role is federated user, and the fourth use case of roles is web identity federation. So we have some links to some security white papers, and then IAM best practice, and STS is the security token service. So whenever you use a role, or whenever you're basically, if I go back, whenever there's a federated user, or whenever we're using web identity federation, it's STS. It's that service that's giving you that basically temporary credentials. So web identity federation would be an example of that. Would be, let's just say you write a web app, and then you want to authenticate users who are going to use their Google or their Facebook username and password. So social users, just think of social users for web identity federation. Okay, a question, a sample exam question would be, your AWS account administrator left your company today. The administrator had access to the root user and a personal IAM administrator account. With these accounts, he generated other IAM users and keys. Which of the following should you do today to protect your AWS infrastructure? Select 3 answers. Okay, so the administrator left, and he had access to the root user, and he had a IAM administrator account. And basically, he generated other IAM users and keys, right? So, well, first of all, it would be a good idea to change the password and add MFA to the root user. It's always good practice to rotate the root user password and to also enable MFA for root. Put an IP restriction on a root. We can't do that. Okay, and then I have rotate keys and change password for IAM users. That's a best practice to always do. Now, delete all IAM users. That's a bit of an overkill. You don't need to do all that. But it would be a good idea to delete the administrator IAM user. Just, you can create a new one, create a new password for the administrator, because you don't want to keep the same one. And then the other one says relaunch all EC2 instances with new roles. So roles, remember, are temporary credentials, and they dynamically get generated. So you don't need to do the last one. If you hard-coded the credential, that would be a different story, and that's usually not a best practice. So that's why it's always good to use roles on EC2. Okay, you have a newly developed application hosted on Amazon EC2 instance, and this application needs access to Amazon DynamoDB. So you have an application that you wrote, that you're running on EC2, and it needs some kind of dynamic credentials. So, or temporary credentials, I should say, that are dynamically created, and that way you don't have to maintain them. Which of the following is the most secure way for the application to access DynamoDB? So most secure, and you have an app that is accessing DynamoDB tables. So let's go to A for a second. It says configure credentials on EC2 instance user data for automation. You definitely don't want to do that. You definitely don't want to store the credentials in Amazon S3. And so again, the best answer whenever you have this type of question, and the application is sitting in AWS on EC2 because it's EC2 is in AWS, and EC2 supports roles, and you could add, modify roles anytime when the EC2 is either running or when you launch an EC2. So what you want to do is add a role to that EC2 instance, and that role, again, can have policy files attached to it. So again, it has a trust relationship that says who is going to assume that role. In this case, it's EC2. And then it has a policy file that says any API calls that are made to DynamoDB basically are going to be signed requests. So basically, EC2 can talk to DynamoDB. So determine how to secure data. So make sure you review data encryption, server-side encryption versus client-side. So server-side encryption, you have S3 managed keys, you have KMS, and then you have customer provided keys, and then the client side. So KMS is our key management service. So it allows you to have a bit more control over the creating the master keys, rotating the master keys, and specify who's allowed to create and rotate master keys, and then who's allowed to encrypt and decrypt data. So that's the key management service. And we have all the following services that integrate or that can be we can use with KMS. Now, then you have Cloud HSM, and that's a hardware-based key management system. So it's an appliance, and it can securely generate and store keys for you. Make sure you review. I gave you a copy of this table in the notes, so make sure that you review the difference between Cloud HSM and KMS, and look at the second where it says single tenant versus multi-tenant. The compliance level 3 FIPS 140-2 level 3 is with Cloud HSM, where KMS is up to level 2. And then the master key with KMS versus Cloud HSM, and then basically the high availability, it's up to the customer to set it up in a highly available environment for Cloud HSM, and then symmetric and asymmetric encryption for Cloud HSM. Okay, so you will have a whole bunch of slides on, links to that. Those, all that is going to be in the notes. So let's take a look at some exam questions. A company uses EBS volumes to store critical and confidential data hosted on their EC2 instance. A new mandate has been released requiring the company to encrypt all EBS volumes. So which of the following can be used to meet this requirement? You have EBS volumes, critical and confidential data, and then I need encryption. So I need to encrypt all EBS volumes. So remember that when it comes to encryption, you have data that is encrypted, but you also have the concept of keys, right? So the best way to basically encrypt the data, so what you can do is say, I want maybe server-side encryption, or I want to enable encryption on that EBS volume. And then what you can do is use key management service for your keys. And KMS, again, allows you to create your master keys if you want. And then it allows you to select the master key that you created, so that way it's going to be used to encrypt your data. So define the networking infrastructure for a single VPC application. So now we're going to get into networking a bit. So it's really important that you understand what a VPC is, how a VPC has a CIDR, which really determines the pool of private IP addresses for that VPC. And then within a VPC, you can have public and private subnets. You can also have what we call protected subnets, but the idea is by default, a VPC is isolated. And whenever you create subnets within a VPC, they are not accessible. They are private subnets, so they're not accessible from the outside unless you set up internet gateway and you set up route table. So there are a few steps there. So you need to understand what routing is, how it works, and then also what's the difference between where and what is a NAT gateway. Now, there's also the concept of security groups and network ACLs. So let's review this a bit. So when you create a VPC, the next step is you create subnets. And by default, when you create subnets, it is a private subnet. There's no entry in the routing table to an internet gateway. And let's just say now you add an internet gateway. And usually the IGW, the internet gateway, is added to the VPC, by the way. So you create an internet gateway, which is a managed service. You attach it to the VPC. So now what you do is to make the subnet public, you go and add in your routing table an entry, something like 0.0.0/0, and then IGW, which means that if you want packets to go out and in, to go to or from the internet, you could now have any subnets that you associate with this routing table will have direct access to the public internet. So a few steps here. So you had first an IGW attached to the VPC. And then what you did is you created a best practice would be create a new routing table, add an entry for the internet gateway, and then associate the subnets that you want with that public route table. And now they'll be able to packets will go in and out to the internet. Now, one more thing on this slide, let's go back to the right side where it says private subnet. So let's just say now I have an application sitting in a private subnet, and it needs basically to do a YUM update. Well, data needs to go out, but I don't want people on the internet accessing this application, so I'm not going to put it in the public subnet. I'm going to leave it in my private subnet, and I'm going to go spin up maybe a managed NAT, and my NAT will sit in my public subnet. So we're going to take a look at a design in a second to explain that. Now, make sure you understand the difference between security groups and network ACL. So security group is mandatory, and a security group is tied to an EC2, or more specifically to the elastic network interface of the EC2. And the security group, the big thing here is it is stateful. So you have stateful means that if I set up SSH, I create an allow rule for SSH, I'm going to use the same connection for the traffic inbound and outbound for that security group for when someone does a SSH. I don't need to go create inbound and outbound rules. I can just say inbound, allow SSH port, and now I basically can have traffic go through that connection. Then I can have, so security group are at the ENI level, elastic network interface. And by default, the default access is allow all egress traffic and deny all ingress traffic. So you have to open up the port to allow the ingress traffic. Where a network ACL, a NACL, is at the subnet level, and it is stateless. Big thing here, stateless. And there are orders. All rules are processed in order when deciding whether to allow traffic. And again, it's configured at the subnet level. Now, the default setting is allow ingress and egress. So it's not mandatory. So the default is allow all ingress and egress. And then in terms of rule, you have to create allow rules and deny rules. So best practice is if you have an application tier and you have a database tier, so what you would do is set up a security group at your app tier, set up a security group at your database tier, and what you want to do is for the database tier, for the source, it would be the security group of the app tier and not everyone. So you want to open up the port for the database tier, and for the source is the app tier. So just be careful with that. And you can have, for connections to your VPC, you can have, we said, internet gateway. You could have, on the VPC, if you want to use VPN and direct connect with your on-prem, then you would have a virtual private gateway on the VPC. And then direct connect is basically a dedicated pipe between your on-prem and AWS. You could have where the difference between direct connect and VPN, where VPN shares the internet, but it's an IPsec connection. And then you can have VPC peering allows you to connect two VPCs together. And then you can have what we call NAT gateways. So let's take a look at this example. So the first thing I want to show you is if you look at the private subnet, I want this EC2 that's sitting in the private subnet to do, let's pretend a yum install. Well, that could only happen if I have on the right, in the public subnet, what I have is a NAT instance. I can have a managed NAT, or I can create my own NAT. In this case, I have a NAT instance. So what I need to do on the private subnet is create a route table, and my route table has an entry that says go through that NAT to get to the outside. So you see that I have my private subnet. I'm going to have a route table, and look at the route table. It says in my private subnet, that route table for the private subnet that is associated with that route table says go through the NAT, and the NAT is sitting in the public subnet, and that will get me to the outside. The NAT is sitting in the public subnet, and my EC2 in the private subnet is associated with that route table. Very important to understand this picture, this design. Okay, so you'll have all kind of links for that. Sample exam question, you're required to design an online application running in a VPC on an EC2 instance behind an ELB. The application tier must read and write data to a customer-managed database cluster. There should be no access to the database from the internet, but the cluster must be able to obtain software patches from the internet. Okay, so which solution meets these requirements? So I have an online application running in a VPC on an EC2 instance. The database, no access, so we definitely want it in a private subnet, the database. But then the application needs to go get software patches, so maybe it needs to do some kind of yum install. So if you take a look at this, it says the first one, public subnet for both app tier and database tier. Right away, the fact that it said public subnet for app and database tier, especially that database, that's a no-no. The second one says public subnet for app tier and private subnet for database tier. But we specifically tell you that there should be no access to the database, and that the online application sitting behind an ELB, and that we're just going to be able, we just want to be able to go out with that, right, to do some software patch updates. So let's take a look at what we have here. So I have public subnet for the app tier and the NAT gateway, and private subnet for the database. And then I have public subnet for the app tier and private subnet for the database cluster and NAT gateway. Well, here's the thing. Normally, I would want almost everything in the private subnet and just leave the NAT in my public subnet. So I never want the NAT gateway to be in the private subnet. That eliminates option D for sure. My database is going to be in the private subnet. Now, I could have put my app tier also in a private subnet and just put the NAT. So in this case, my only choice left, because everything here is public subnet. So public subnet with the app tier and NAT gateway, and then private subnet for the database cluster seems to be the best answer. But it's not uncommon, I just want to go back a bit, to have an application sitting in a private subnet and my NAT gateway sitting in the public subnet, and everything else is always sitting in a private subnet. So here, like on the left side, see I have my NAT sitting in a public subnet, and my application, I have EC2 instances in a private subnet. It's not uncommon to have that. Just be careful a bit with that. So you have deployed an instance running a web server. When you try to connect using HTTP over the internet, the connection times out. So which of these steps could fix the problem? So this is, again, you want to make sure that your route table is accurate. So it has an entry that says 0.0.0/0, and then it has an entry for the internet gateway. You want to make sure that because this is a web server, that you have port 80 that is open for the security group. And if you did create some custom NACLs, well, then you want to open up the inbound access port on port 80. So just check if you have some custom NACL or network ACLs in place. So always make sure that you log down the AWS root user, the account root user, lock it down. Security groups only allow, network ACLs allow, and you have to explicitly deny. And then always use roles. So prefer IAM roles to access keys. So let's take a look at the notes. So in domain 3, you have some links for your best practices to manage AWS access keys. Think about roles. I have some information about data encryption for server-side encryption with KMS, server-side encryption with customer-provided keys. Make sure you understand all these different acronyms right there. So this is the comparison of Cloud HSM to KMS. Some additional links, and then you have the whole idea of security groups versus network ACLs, public subnet versus private subnet. And I put this design so you can remember that the NAT itself can be a managed NAT, or it could be an instance that you basically launched. And then that sits in a public subnet, and you can have your app server in a private subnet as long as the route table says whenever I do a YUM update, just go through that NAT. And then, of course, for your public subnet, you would have a route table that has the entry for the internet gateway. So make sure you review that, and you're very comfortable with that. Okay. One more thing. Near the end of this doc, as I'm going through all that, so I put an example of a reference architecture for WordPress hosting. But the goal really that I wanted to achieve with that is every little component on this reference architecture, you need to be familiar with it and understand how the data, so when a request comes in, what does CloudFront do? See how I have an internet gateway, see how I have my NAT in this use case. So take a look at that. Look at the auto scaling. I have my database. I have my master, and I have master usually in a standby or a primary and a secondary, if you want to call them. I would have read replicas. I have EFS. I have S3. Right, so take a look at where S3 sits if you did have S3. So always make sure you look at a reference architecture when you're studying for this exam. Okay, let's go to domain 4. Now, designing cost-optimized architectures. So we said that when we're designing an architecture, we can be using EC2, we can be using serverless, we could be using storage such as EBS, we can be using object storage, and then there's the data transfer aspect of it. So when you're looking at S3, we have the different storage classes. We have the storage cost itself, and then we have the API request, and then we have data transfer out, but data transfer in is at there's no cost to that. So this is just an example. So you have standard storage and infrequent access, right? And they're just showing you that usually when you have standard storage, that's going to be a bit more expensive than a frequent access. And then you can also have one zone and you can have Glacier. So Glacier is the less expensive compared to infrequent access and standard storage, because Glacier is really used for archiving. So this is an example of pricing, but this is the storage side of it. Now back to S3. We said that there's the API request side of it too, and then there's the transfer out. Just keep that in mind. When you're looking at EBS pricing, you have the volume type. So you can have, we said, SSD versus provisioned, standard SSD version provisioned IOPS, right? And you could also have cold, if you want HDD, so you have SSD versus HDD. Then you have, for provisioned IOPS, you have additional cost for the IOPS. And then you can take snapshots. So when you take snapshots of EBS, the first snapshot is a full snapshot, but the other snapshots are incremental snapshots. And then another thing with EBS is that when you create a volume, if you create a 1 terabyte volume, so your cost is on how much you create and not how much you use. So if you create a 1 terabyte and you only use 200 gig, you're going to be charged for the 1 terabyte. So just make sure that you're aware of that. So if you bring up the EC2 instance and you add additional volumes and you terminate the EC2 instance and you don't have to delete on termination for your other EBS volume, then you have these unattached EBS volumes. So what you want to do is anything that is unattached, you want to delete them or go look for them. You could resize, just make sure you're aware that you can resize or change the EBS volume type. And then if you have too many snapshots or they're stale, you can also delete your EBS snapshots. So you're trying to be cost conscious. And what you may want to look at is there's a way to take a look at if your what pricing looks like, or if you're exceeding your the cost, so there's some best practices around that. And some of these best practices is basically to go delete EBS volumes, maybe clean up a bit your snapshots, resize EBS volumes that are not being, if they're too big, so things like that. So as an example, by the way, I did want to mention there's a tool called Trusted Advisor. You may want to look at the different elements in Trusted Advisor. One of them is cost optimization. One of them is security. So cost optimization will give you an indication on how much money you can save. So take a look at that. Anyway, so exam question. You are asked to make a PDF file publicly available on the web. This file will be downloaded by customers using their browsers millions of times, right? So which option will be the most cost effective? So let's take a look at this. It is going to be publicly available on the web, and this file will be downloaded by browsers, and we want the most cost effective. So here we just need to be careful a bit. Now, Glacier is definitely out of the question in this case, and for anything that is infrequent access, which is the other tier of S3, it is cheaper, but you're going to be paying for the retrieval. And my last one, it's a bit hidden in the slide. Let's just adjust this a bit for you. Well, sorry about that. So let me just go like this so that way you can see everything. There you go. So the last one that we have in this slide right here, it says EFS. So that's really not a good option in this case with EFS, because EFS is for if you want to share a file system between EC2, and we're talking about here a publicly available on the web. It doesn't have the HTTPS endpoint for that object. So basically, your best answer in this case is store the file at Amazon S3 standard. Okay, serverless architecture. So recognize that in some use cases, it's more cost effective to use a serverless architecture. So how do we charge for Lambda? Lambda is based on invocation time and the amount of memory that is proportional that you're using for that Lambda service. So S3 is serverless, Lambda is serverless, DynamoDB is by RCUs and WCUs. And then we have another, usually part of an architecture, you can also have API gateway as part of your serverless architecture. So CloudFront is our CDN. And the benefit of using CloudFront with S3 is that there's no cost for the data transfer between S3 and CloudFront. So a good use case would be if I'm always getting objects from S3, I'm always reading objects from S3. If I have cache from CloudFront, well then the object is going to be in cache in one of those edge locations. And that way, instead of always going to the origin and occurring a cost, a request cost, you can always just hit CloudFront because the file or the object has already been cached. So that's a great way to reduce costs. So it can be used to reduce the compute workload for EC2 instance. And then cost consideration, traffic, request, data transfer out for CloudFront. So caching with CloudFront can improve both performance and cost optimization. This is key. This last bullet point is key. So consideration for EC2 instance. So you have with EC2, you could have, based on if it's a Linux AMI, you could just be paying per second rounded off to the minute, right? So you have to look at, how long an instance is running, the instance family, the different sizes, that can affect cost. Right? If you're using an elastic IP or you just have an elastic IP laying around in your environment, that would definitely add more cost. And by the way, an elastic IP is a static public IP that you can attach and detach to an EC2 instance. And what you want to look at in terms of how to save money is you can have reserved instances where you can save up to 75%, and under reserved, you can have standard, convertible, and scheduled. And then you can have spot instances, which is spare compute capacity in AWS. So, and those are also discounted, heavily discounted. Now, example of a question. So you have to know so the right use cases for spot and the right use cases for reserve versus on demand. So you can have reserved instances, spot instances, on demand. So as a sample exam question, you have to run a batch job every Sunday night. The job completes in less than 90 minutes and cannot be postponed. So which Amazon EC2 payment model should you use for the best price? So a few things right here. So first of all, it says it cannot be postponed. It is every Sunday night, so we're kind of giving you a hint that there's a schedule involved. So in this use case, it would be a scheduled reserved instance, so it's still good price, and you can have it scheduled every night, and it could be like the reserved instances we said right here. They are discounted compared to on-demand pricing. And under reserved, you can have scheduled RIs. Okay. So exam consideration, if you know it's going to always be on, it should be a reserved instance. Determine the most cost-effective EC2 pricing model and instance type for each workload. Make sure you understand the different instance type. Wouldn't be a bad thing to just Google AWS EC2 instance type and review the different instance type. And then any unused CPU time is a waste of money, and use the most cost-effective data storage service and class. So make sure, again, you review the different types of data storage tiers for F3. Let's go to the documentation a bit. So I'm going to go to domain 4, which is pricing. So we have always make sure that you review the different pricing, understand how some services are priced a bit, especially F3, I would say, more than anything else in EBS. Here also, maybe it would be also a good idea to understand what's the difference also between SQS and SNS. Now that I'm looking at this, I do have it in a different also section, but we didn't really. So for the exam, just make sure you look at the design of, maybe a fan out with SQS and SNS together, just a heads up. So with SNS, you have the pub sub model where you can have multiple subscribers, and then SQS uses queues, and that uses the polling model. So that's pretty important. And you have the EBS pricing. Just review a bit how EBS is priced. And then the benefit of using CloudFront with S3. So in terms of performance and cost. And then understand the different, what in the reserved instance, what you can have. So like standard convertible. And then EC2 spot, how the idea is you can have spot instances, what the use cases are. So what you want is for various fault-tolerant flexible applications. That's the key word here, flexible application, such as big data, containerized workloads. So you need to be able to withdraw the fact that if you lose the instance within 2 minutes, you'll be okay with it, because just keep in mind that spot instances can be interrupted. That's the key word here by Amazon, with 2 minutes of notification. So a heads up. Now, just make sure you know that spot instance, basically you can have spot blocks, which enable running instances for 1 to 6 hours without interruptions. And that's an option also that is available. So just be aware of that. And then some links, and there's your consideration, exam consideration, what we reviewed. Okay, so that is for spot. Now let's, for cost, let's go back to the last domain. So operational excellence. So once you have an architecture and design, what you want to do is continually, run, monitor systems. And what you're doing is also delivering business processes and procedures. So some of the design principles is anticipate failure, perform operations with code, learn from operational failures, make frequent small reversible changes, right? So some of the services around operational excellence is, at a high level, you just need to know about this. So I did talk or briefly introduced AWS Trusted Advisor. So Trusted Advisor scans your environment and provides best practices around different categories such as cost optimization, security, performance, also gives you what your limits look like, right? Fault tolerance, like it'll tell you if your snapshots are out of date. It'll tell you where you can save money in terms of cost. Security will tell you if your security groups have incoming or port opens like for 0.0/0. So just take a look at Trusted Advisor. I think we talked about CloudFormation enough. Now, AWS Config allows you to take a snapshot of your environment and gives you historical information on things that have changed in your environment. And then what you can do is also set up rules to be triggered if you're non-compliant. So it's great in terms of setting up rules around compliance and governance and security. Then you have AWS Inspector. Inspector allows you to inspect an EC2 instance to see if there's any open ports, if it's not meeting some patch requirement. And then you have CloudTrail. CloudTrail is for auditing API calls. And then when you set up VPC, you can enable VPC flow logs, and flow logs allows you to trace the flow of a packet as it goes in and out of your VPC. It's not there to inspect the content or any packet filtering or anything, but it just shows you the flow, the source, the destination for your packets, and if it was accepted or rejected. So that's VPC flow log. It could be enabled at the VPC level, at the subnet, at the ENI level. So those are all part of operational excellence support services. Now, when we talked about CloudWatch, one of the features of CloudWatch is it has a component for metrics. It can collect CPU metric information, so performance information, and then what you can also do is create custom metrics, and you can set up alarms, and alarms can send notifications like email if you want via SNS, simple notification service. And what we've seen also is CloudWatch is also tied to auto scaling. When you set up an auto scaling group, you basically could scale out based on a trigger from CloudWatch, like your CPU is over 80%. Now, once metrics are collected in CloudWatch, and they're collected every 5 minutes, you can have detailed monitoring. So that is every minute if you want. And then to view statistics about the metric, you can use the console, or you can even have a third-party app that has the API plugin and collects that data and gives you a visualization of those metrics. So to monitor CPU utilization on your RDS database instance, you set up a CloudWatch alarm with a threshold of 70% over 3 periods of 5 minutes. If CPU utilization goes up to 80% for 10 minutes, how many alarms will you receive? This is a sample question. So remember that here we have 3 periods of 5 minutes, and that's when basically you'll get an alarm. But here it only went up to 80% for 10 minutes, so metric did not exceed threshold of 15 minutes. So the answer is 0. Next question. Oops. You are responsible for a web application running on EC2 instance, you want to track the number of 404 errors that users see in the application. Which of the following options can you use to do this? So let's take a look at this. So you have your response. So it's a web application running on EC2, 404 errors. So maybe I can explain this a bit more. Now, with CloudWatch, I mentioned that you have alarms, you can have metrics, but you can also, with CloudWatch, is install an agent on an EC2 instance. And when you install that agent on the EC2 instance, you can configure a file to say, I want to collect data from different application logs. So it could be an Apache application log file, it could be an Apache log file, it could be an application log file. Any log files that are sitting on that EC2 basically are going to be collected with that CloudWatch agent and sent to CloudWatch logs as a log stream. And now that you have that log stream, you can go you can go to CloudWatch logs and filter out if you want for 404 errors. So that's another feature that is available with CloudWatch. It's called CloudWatch logs. So that's something that you want to look at. So VPC flow logs is not a good answer because flow logs capture layer 3 and 4 level logs, doesn't capture layer 7. And metrics, well, this is not a metrics per se, right? So metrics would be like CPU, that would be a metric. Memory, even though it's not out of the box, but that would be a metric. You can install a package to get memory metric. And then 404 errors wouldn't be considered in terms of CloudWatch metric. So then the last one, which says web applications on AWS never have 404 errors. They can. So web applications on AWS can have. So the best answer really is C. Now you have written an application that needs access to a particular bucket in Amazon S3. The application will run on EC2 instance. What should you do to give the application access to the bucket securely? So store your access key and secret key on Amazon EC2. No. You don't want to do that. So you never want to do that. And it says, store your home access key and secret key again on the Amazon EC2 in the credentials. No. And then use Amazon S3 bucket policies to make the bucket public. You don't need to do that. That's you don't want to give access to everyone, because when you make something public, you're giving it broad access. So again, the best, whenever you have an application that needs access to a particular bucket, and you know that the application is running on EC2, so it's in AWS, right? So roles, IAM role would be always, when it's in AWS, is always the best option. So attach an IAM role to the EC2 instance with a policy that grants access to the bucket in S3. That's always the best answer. So monitor metrics across the system, provide alerts, automate the responses to metrics, and then IAM roles are safer than keys and password. Always consider that. So now that was all the domains. And just quickly before we actually wrap up, is I want to spend a bit more time on the document. So again, just to make sure you are right here, you're going to be doing the associate. And what I want to do is just close this and go back to the reference document. So we're back to the beginning right here. Now, what I also have is the exam guide, so you can follow the different sections that you need to study. And don't forget that one of the sections, which is domain number 2, one of the largest sections is domain number 2, where you have a lot of the services are in domain 2 or design performance architecture. So you want to make sure that you go through all the services, like what is RDS? And I want to just point out a few things here. So RDS is available for Aurora, MySQL, PostgreSQL, Aurora, Microsoft SQL, and MariaDB. So just make sure you're aware of that. And some things that I put in blue here, when they start talking about read replicas are available for MySQL, MariaDB, PostgreSQL, as well as Aurora. So make sure you know that. Again, the difference on when to use RDS and when not to use RDS. And then make sure you understand the use cases for DynamoDB, right? So you need single-digit millisecond latency and any scale such as mobile, web, gaming, IoT, and many other applications. And then DynamoDB is also great when you need sometimes to store session information, right? That would be a NoSQL database. You can also use distributed cache for that, though. And then DynamoDB works with provision throughput for RCUs and WCUs. Make sure that you are able to distinguish between a data warehouse, which is for analytics, versus a relational database, which is a lot of reads and writes. And under caching, make sure you understand that under caching, you can have Elasticache that supports Redis and Memcached. So that's for Elasticache versus front end, where you have CloudFront, which is our CDN. And then on the back end, we have, when you set up CloudFront, you can have different origins. So make sure you review that. And then for when you're designing your solution and you're using autoscaling, you should review EC2 autoscaling versus AWS autoscaling. And then when you're doing EC2 autoscaling, you should go review the launch configuration and how you create autoscaling groups. And then within the group, after you set up your scale out and scale in rules, review all that. So make sure you review the difference again between SQS and SNS. So all that is in here. And in securing your application, just remember roles. Always use roles when you're in AWS. Make sure you understand your data. How data, you can encrypt client-side encryption. You can the difference between Cloud HSM and KMS. And then the biggest thing is your networking. Make sure you understand VPCs, subnets, security group, internet gateway, direct connect, VPN, NAT, and route table. Now, VPN and direct connect, you only need to understand it at a very high level, but security groups are very important. So the difference, how you would set up your security groups between the different tiers, and the difference also between private, what makes a subnet public versus what makes it private. So really, if you have an entry in the route table for the internet gateway and your EC2 has a public IP address and there's an IGW attached to the VPC, well, it takes all that to have a public subnet. Look at some design references. Always good to look at some design references. And then we talked about cost. So I believe we went through all that. So that piece we're good. And then at the end, when we go through a design like this, let's spend a bit more time on design, because you need to picture that when you're doing the exam. So here I have users are accessing a website, right? So you have Route 53. Make sure you understand what Route 53 does. It basically resolves domain names to IP address. It's a resolver and vice versa. And then you have CloudFront for your CDN. Look where it sits. So CloudFront represents the CDN for all the edge locations. So user makes a request. The request checks if it's in the edge location. If the edge location, if it's not found there, it basically goes to the application load balancer, and then the application load balancer goes and hits the WordPress instance right here. So load balancers, WordPress, that could be an origin. And then you have memcached. So you have the application needs to go retrieve data from the database. Well, you can have a cache here, and it could be memcached. You can have read replicas if you want, or you can have also, so you have your master database. You can have, in Aurora, you can have a reader that, and then that could be also promoted to a master. Then you have on, if you want to share a file system between EC2, you have an EFS as a service. There you go. You have EFS as a service. And EFS, you can have clients sitting in an AZ, and they can, basically your EC2 clients can share a file system between EFS or on the EFS basically backend if you want. But if you do have if you have an EBS, the EBS is tied to an EC2. So for the exam, it wouldn't be a bad thing to review some reference architecture to make sure you can understand the flow. And then at the end right here, if you needed like a S3 bucket somewhere, where would S3 sit? It would sit in the region. So just make sure you understand where S3 sits also. And then for the load balancers, you need to review the application load balancer versus a network load balancer. So that's an example of what you need to review for the exam also. And then just one more little thing. I am going to just go and bring up. So what you want to do is when you go to aws.amazon.com/architecture, that's one link you want to review, and a whole bunch of white papers that we pointed to is really sitting under this site. And there's your reference architecture diagrams. And I went and took the one of WordPress because it's a common one, but you can also review additional architecture. But I think the document that I put together is more than enough. Plus, if you attended the class, make sure you review some of the designs in the class. So let me just go back. One more thing here. So this would be the exam that you're doing, and you want to review anything around highly available, cost-efficient, fault-tolerant. That's going to be your focus. So it's really design review more than anything else. And that's really it. Are there still questions that are unanswered, or we're finishing up with questions?
Yep, it looks like there's a couple questions in the questions box, so we can spend a few minutes answering those, but otherwise I think we're good.